Hey there, so I'm just making this video to show the progress that I've made on the project. So here goes. First things first, if you want to know where all my code is stored, please go to github.com/research/tensorflow. All right. In here, the fourth line from the bottom, the one that I built 9 hours ago, this is where my code is stored. All right. And this is the name of the file, Team17 CNN LSTM IPYNB. All right. And as you can see, I'm running this code in this environment, co-laboratory. All right. So that is what I use to run my code. That's my runtime environment for the code. All right. So let's go to the runtime environment now. Okay. The first line of code here is very simple. It just tells TensorFlow, make use of the GPU. So let's run this code to install it. I clear the environment fully so that we have a fresh run. So please bear with me when it installs all these packages. Okay. All right. As you can see, the RAM is, we have enough RAM and we have enough space on the disk. So that's good. So let me also go and check the runtime because I want to make sure we are running it on the GPU and not the CPU. All right. Let's go and have a look at that. Good. It's running it on the GPU. All right. Right. It's downloading stuff. I guess it's done. And let's see. Requirement satisfied. Installing the package. Installation is almost done. And actually, I like to do it in real time so you can follow the process along with me. Ooh, but the disk space is pretty high. I'm a little bit concerned if it's going to crash on me because of this. Let's see. All right, now I have to point to the drive where the information is stored. Drive is already mounted, it says, so that's good. Let us do an import of the helpful libraries that I will need to run my stuff. All the libraries have been loaded. I think I already set the path, so I don't want to reset it again. So let's just list out the directories. Oh, we are not pointing to the directory of interest. The directory of interest is stored here, okay? It's my drive, Colab notebooks. So I set the path to that. Okay, now I'm pointing to that path. I hit ls. Now you can see all the contents. Here, there are certain files of interest, all right? So the first file is the clean data. And like the second one is where we have the noise that has been introduced into the signals. So the first one would be what we expect, and the noisy data is what we send into the network. All right. So next few sets of lines are very simple. You just read the contents of those files and you transform them into a form so they can be fed into the neural network. All right, that's about it. I was just reading those lines from the file. Let's see how long it's going to take. And it's done. All right, so now here, this set of lines just reshapes the file and you can see the shape of the files over here. You can see how long it is, etc., etc. And then I have another set of lines to do the reshape to finally send it into the neural network. I'll see if I can show you the dimensions. If it doesn't work, please bear with me. You have to excuse me for that. X-train reshape. Okay, let's see what this just gives. I think it will give me the, okay, it just shows all the data. But let me see if I can get the shape. Sometimes the shape thing does not work for this. So I don't want to waste time. You can see the shape. See, you got 9 of them and 30,000 rows of, okay, you have 30,000 as the height and it's a single column and it has a depth of 1. Okay, you feed the data into the CNN as 4D. All right, so let me print. So let's print more information and see. Let's see what we can get for training data. I'm curious to see that. It's been a while. Dot shape. And let's see what comes of this. Cool. So this is the training data. As you can see, the training data is more than the test data. Right? That's it. Okay. Now let me run the model. I'm really concerned because Look at the disk space. It's already consumed. I hope it doesn't crash on me. Sometimes when they give you space, they give you some machines that have already been used. So I'm a little bit concerned, but I hope it drains. No, it doesn't drain. I knew it wouldn't drain because of this. All right, guys. So you know what I'm going to do? I can like reset the runtime and then I can run it again, or I can run it on a CPU. Okay, so I'm going to change it to a CPU. I'm really sorry about that. So let me change it to a CPU now, and I have to do all the steps again. So please bear with me, and hopefully the CPU. Okay, the CPU has more disk space. All right, so I don't need this stuff. I think I have to remount it again because I changed my runtime, right? Okay, so let me go. I need to get authentication to be able to do that. So come on, man, Google, do this for me. All right, sign in. I get this authentication token. I feed the authentication token in here. I hit enter, and then I have to import my libraries again, but I have to wait for this to get authorized. Good, it's authorized. Oh boy, I run this, and it's the same old, okay? So I'm not going to repeat all these steps because you already saw it. It would have been so nice if the GPU worked. So I have to reduce the size of how many times I run through the data for my training cycles, okay? I'll only be training it for 10 cycles now because training it on the CPU is very slow. All right, so again, reshape the data, again, do all this stuff. All right, now here, this is the definition of my CNN layer. You have a conf layer followed by some normalization done inside the layers, okay? Each layer has a batch normalization. So that's the key. Followed by activations. And then you have a pooling layer. And I used what they use for pooling. I would have used max pooling, but these guys used average. So I was forced to use that. All right. So I replicate that same combo 6 times, and then I have to flatten out the output, and I send it through another unit, fully linked, layer. Then I get the output, which is compared against what we expect. So like the optimizer that I use is Adam, and the loss function against which we use is MSC, mean squared error. All right, so now let's run it, but I need to reduce the number of training cycles. I'm changing the epoch to 10. All right, and then let's train again. This time it should train on the CPU, but it'll be a little bit slow. But this is the first pass, so the neural network has no trained. So the neural network has not been trained on anything, right? This is the first time it's getting trained. Let us see what the output will be. Okay, so while it's training, let me explain a few other things about my code. All right, so these are the lines you use to plot the output. All right, so once it finishes training, it'll we are actually looking at some values here. They will be shown on a graph. So as you see here, we do the plots on the graph for these metrics. You can put a lot of metrics, but I'm only looking at MSC because that is the only thing that matters for our training. Okay. All right. So what else is important? Fun here. Okay. This line shows you the internal structures of your neural network in terms of this output. So this is very useful because you can use it when you're making your neural network to make sure that the structure is sound and right, etc., etc. It also shows the batch normalization, like sizes. So how many things get trained in each layer and such very useful information. All right, so the training is still going on because it's a CPU. It's very slow. We have to do 5 more, runs on the data. But we will get there. We will definitely get there. Okay, so while that is going on, I also wanted to show you like another neural network that I built. And so this one is the long short-term memory network. Unfortunately, I can't run this network, that's because it takes a very long time to train. Even if you use the GPU, if I use the CPU, I'll have to wait for a day, and only then this video will be over. I'm sorry about that. All right. So if you want to see the structures of this network, once again, you can see the information here, which is a result of using, this line over here that just outputs the internal structures. Okay. All right. Let's see how the training is doing now. 2 more epochs to go. Okay, but let's have a look at the data. Has there been any improvement? There seems to be like a drop. You see, it was high, it is slowly falling down. That is a good sign. Okay, so what about the validation? The validation is not exactly like in sync, right? That may be because it doesn't have enough training samples. I could increase the training samples to see what is going on. But I'm expecting we have a graph where so the data you use to train is fit very well, but what you use to validate is going to go off in a tangent. Okay, that is a clear case of like the data getting the network getting too closely trained. See, we have a big divergence. It's not good. It's a clear sign of over fitting the data, like to the training samples. So one way around this is I need more training samples. If I have more training samples, the neural network should be able to learn from a wide variety, from like a wide range of data. But for now, like this is the output that I've got, and I'm hoping that with more training samples it should be better. So I guess that's about it for this presentation. I hope you enjoyed it. I just wanted to do a run through to show you, and I hope I didn't bore you too much. So I guess that's about it. And I will be stopping the recording now. And that's it. Bye-bye. How do I stop recording now?